Hello, everyone. I'm your host, Sarah R. Welcome to the new season of the Wikimedia Tech Talks, which are backed by popular demand. Tech Talks are an opportunity for individuals from the technical community to share what they know. Going forward, we'll host in-depth talks on technical topics about once a month. There will also be other opportunities for sharing in the future, including shorter lightning talks and demos. We'll share more information soon. Tech Talks are open to everyone, so if you have an idea for one, please feel free to contact me either by email or on IRC, and both of these things are on the slide in front of you, or follow the instructions on the MediaWiki link that's also on this slide. Today's speaker is Subbu Sastry. He's the principal software engineer on the contributors team at WMF, and he will be speaking on the long and winding road to making Parsoid the default MediaWiki parser. There will be some time for questions at the end, and you can ask these in IRC on the YouTube stream, or if you're in the San Francisco office, please come up to the mic and ask your question. And without further ado, I will let Subbu take it.
Thank you, Sarah. Let's see. Okay, do you see this?
Yes.
All right, okay. Good morning, everyone. And my name is Subbu, and I'm going to talk about making Parsoid the default parser for MediaWiki. And so on the parsing team, our mission is threefold. It's about Wikitext, the output of the parser, which is HTML, and about the parser itself. And today I'm going to focus primarily on the last piece. That is, how do we use the same parser for reads as well as edits? And that begs the question, what exactly are the two parsers, right? So that's going to be as part of the background in the first part of this talk. I'm going to tell you what the two parsers are, why we have two parsers, how they are different, and what is the core reason why we have two parsers today. And as part of that, I'm going to talk a little bit about some details about HTML, the DOM, Wikitext, and how Wikitext behaves, and how Parsoid tackles this. And in the second part, once we have the background, it's easier to look at the roadmap in terms of where we started and where we are today, and why we are porting Parsoid to PHP, and how do we get to the end of this road. So first things first, what are the two parsers? So right now, if you look at MediaWiki, there is the default parser, which takes Wikitext and outputs HTML. And there is also Parsoid, which not only can take Wikitext and generate HTML, but it can also go the other direction. It can take the HTML produced by clients like Visual Editor and produce Wikitext. So the default PHP Parser has been in MediaWiki since about 2003. It's currently used for all the desktop read views. It's used by mobile web. It's used by the iOS app. And if you're a client that uses the Action API, then that's also backed by this default PHP parser. So when did Parsoid come into the picture? So Parsoid came in around 2012. It started as a project to support visual editing, but since then it's come to support a lot of other products and tools. So it's used by Flow, content translation. The Android app is backed by Parsoid output. It's used by the 2017 Wikitext editor. The linter extension uses Parsoid, and Google Kiwix offline reader and the REST API. The thing to note is that right now Parsoid is written in Node.js and runs as a separate service. So what does it mean to unify the two parsers, right? So as it turns out, for a bunch of reasons, all the roads essentially lead to making Parsoid that single parser for MediaWiki. So first of all, the current legacy PHP parsers cannot support Parsoid clients. And also importantly, so the output from Parsoid, the HTML that we produce, is annotated with information about the source page, that is about Wikitext. And this information is useful for clients for extracting information about the page that was parsed. And long term, it's really not tenable to have two parsers, and it really hamstrings future work. For example, if we want to evolve Wikitext, we want to fix templates, then if we have these two parsers, then we have to make those changes in both. And that's really not efficient and really slows things down. And so this is something that we've been moving since about 2015, and which is why I'm calling it a long and winding road, because it also goes back all the way to 2011. And here, out of actually played you the Beatles song, but I think I think it may be the case that if I played it, YouTube may take it down for copyright violation, the recording of the tech talk, and we don't want that. But you can imagine the song in your head and how it kind of applies to Parsoid and MediaWiki. Okay, so on to the next slide. So here are some pretty pictures of some long and winding roads, and they are somewhat metaphors for the work that has gone on and that we need to do. Occasionally, it can look treacherous. You go through tunnels, like for example, we are in right now, porting Parsoid to PHP, and you hope you come out soon and get on with two other things, right? And occasionally, it's a nice and clean path. Sometimes it looks like it's the end of the road, but you don't know what's beyond the horizon, and it may even be a pretty picture. Occasionally, it's uphill. So those are all metaphors for the project of Parsoid and where we are going broadly. So let's set the stage for the parser unification with Aladdin's genie. So you might know the story. So Aladdin had been stuck in a cave. He found a lamp, he rubbed it, and out came a genie. And the genie gave him wishes. So let's say we have the genie with us and we could make a wish, right? So we could ask the genie, please port MediaWiki to Node.js, okay, and integrate Parsoid with that. And no services is going to be a monolithic code base. So the question is, now that we have all the code for MediaWiki, Parsoid, all in Node.js, how many parsers will we need today to support our products? Well, you may think we will probably just need one parser, but you're going to be wrong. We'll need two parsers today, right? How about it? We go the other direction. We port Parsoid to PHP. Once again, integrate this with core, no services, right? We have a single code base. All code is in PHP. How many parsers will we need today? Once again, you'll need two parsers. All right, so let's make a different wish. We ask the genie, all right, port Parsoid to PHP, but also fix Parsoid's output and feature differences, and fix extensions that need to be fixed. Then if you ask the question, how many parsers we need, then it's easy to answer. We just need one, and that would be Parsoid written in PHP. Or you could go the other direction. You could ask the genie, port some subset of MediaWiki core and some subset of extensions to Node.js. And once again, fix Parsoid's output and feature differences, including extensions. And if you did that, once again, you'll probably only need a single parser. In this case, Parsoid written in JavaScript. So this might be a little confusing, right? So the point of those slides is to kind of get to the core of why we have two parsers today. It's not because one is written in PHP, another is in Node.js. It's not because of the service architecture, whether we have services or whether it's a monolithic code base. Of course, they do matter. But the core reason and the primary reason why we have two parsers today is because the way they process Wikitext is different. One is based on processing strings and generating strings. And the other is, that's Parsoid, uses a structured representation internally. It uses tokens, it uses the DOM. And so as it turns out, this difference in processing and the difference in pipeline introduces a bunch of differences. And so yes, language and service architecture do matter, but more as constraints on the parser. So they affect the twistiness and length of the road, but are not really the primary reason why we have two parsers today. So to make a little bit more sense of that, what I said there, right? Let's go through, let's understand a little bit about HTML and DOM. So HTML and DOM are web standards. And so if you look at HTML document, it has structure and there is semantics. And this is defined by the web standards. And so DOM is a document object model. It means when you parse a page written in HTML and build the DOM, then you have a structure, and the objects on the DOM have a relationship with each other, and it's all defined by the spec. The reason this is important is because you can use HTML and DOM libraries written in any language. It could be Ruby, PHP, JavaScript, Java, and they all behave the same way. So if you're a client that is looking at the output of Wikipedia, output of a page, then you can analyze the page and extract information from it. You don't have to deal with Wikitext potentially, and which is where we'll come to in a little while. So as an example, let's look at this piece of HTML. And for that, this is how a DOM might look. So a DOM is a tree structure. If you use regular trees, and this is an inverted tree where the root is at the top. So there's an HTML element which has two children, the head and body. Head has a single child, in this case, the title of the document. In this example, the body has two children, the H1 and A tags. And the web standard and the semantics of the spec define what this all means. And so if there are more children of the body, there would be more elements in the DOM. And so given this DOM structure, you can query and manipulate the document. So you can, for example, ask, give me all the headings in the DOM in this document. Or you can ask, give me the second section. Or you could say, give me the first column in the table with the ID badminton tournaments. Or if you're interested in modifying the DOM, you can try to replace the first list item in a list which has a title, which has the ID greatest band with the Beatles, right? You can do this with any DOM library in any language. So the question is, if you look, so given our parsers, we now know that the output has a structure, and you can use libraries to query and manipulate the DOM. So the question is, what about the input document? What kind of structure does the input have? And more importantly, can you map the input and the output? The reason this matters is because if you're trying to answer questions about a wiki page, or you want to manipulate the wiki page, it's important to note that HTML is not the canonical representation of a wiki page. It's Wikitext. Wikitext is the authoritative representation currently. So you cannot really answer queries or manipulate the page by looking at HTML and HTML libraries without having a mapping between the input and output. So for example, if you wanted to ask, give me the info box content and all its parameters, you won't be able to do that. If you say, give me all the citations that come from templates, no, you can't do that. Or if you want to replace this info box with something else, once again, you cannot do that. You could if you parsed and manipulate Wikitext, but that means every single product, every single client that needs to do this would have to deal with Wikitext. And that's not really a scalable and good solution overall. So the question, again, to go back to what I asked earlier, is what kind of structure does Wikitext have? So do Wikitext constructs behave like DOM trees? No, they don't. Wikitext does not have a spec, and hence no formal semantics. So the behavior of Wikitext emerges out of what the legacy PHP parser does. And that parser does not really think in terms of DOM constructs at all. It's primarily concerned about very efficiently constructing the output HTML string. And this makes sense. I mean, this was written in 2003, and at that time, there was no foundation. It was all volunteers. And more importantly, the servers were not as powerful as we do now. And it was very important to do this very efficiently. And that particular design makes good sense. But that's not the case today. And so given this, templates pretty much inherit the same behavior from Wikitext. And so a lot of templates are, once again, primarily about constructing the output HTML string. And any meaning that you might think templates have emerges from conventions and practices and wikis, and not because there is a spec or something that's well defined there. So to make this a little bit more concrete, let's look at an example, right? So here is a piece of Wikitext. And so you have these triple quotes, which signify bolding. And so in there you have foo and bar, and you have a template. And outside you have bars. So foo will be bolded clearly. So the question is bar going to be bolded, right? So that's a trick question. It depends. It will be bolded if your template is one of these three on the first line. So the 1x template is just an echo template. It just outputs as parameters. It's nothing special. But if you had the templates on the second line, bar will not be bolded. So already it's clear that you cannot look at a piece of Wikitext in isolation. It depends on what templates might do and what they expand to. So let's go further. Let's say your template is this 1x with string A, which has bold tags around it. You would think that A would be bolded, right? But the question is, will it be bolded when it's included in the page in that Wikitext above? No, it won't. Foo will be bold, bar will be bold, but A will not be bold. So this particular example I've given here is not at all hypothetical. So recently, when we were replacing tidy, editors had to fix Wikitext pages, and they had to go changing Wikitext to make sure that when tidy was replaced, the rendering will not break. And editors on multiple wikis encountered something very similar to this. So italics the behavior of italicized text would change depending on the kind of template they were using. So you would expect, so I think going back, so you're expecting, looking at the template, that bar would be bold, A would be bold, but in reality, that's not true. This would be possible if Wikitext had independent parsing. That is, if you parse the top level page separately from the template, and then you plug the output in the hole where the template is. So that requires independent parsing, that requires DOM scopes without non-local effects. So that's the state of affairs with Wikitext today. So there are non-local effects in Wikitext, and it has a bunch of implications. It has implications for usability. So for editors and humans, it makes it a little hard to reason about consistently. So you just can't take a look at a string of Wikitext and say what it's going to do. It makes it hard for tooling, because if you're trying to manipulate a page, then you got to deal with all these non-local effects. Thirdly, it makes it hard for getting really high performance, because you really cannot break the page into independent chunks and parse them independently and put it together. You cannot do that, as we just saw. So the question is, how does Parsoid deal with this? So clearly the output has DOM structure. So what Parsoid tries to do is it assumes DOM structures wherever required to make this whole thing work. And given this far input DOM and the real DOM in the output, it tries to compute a mapping between the two. So for example, it treats extension output as an independent document. So that's a DOM fragment technically. It looks at link content and treats it as an independent DOM fragment. It looks at figure captions as DOM fragments. There are a bunch of others like that. But templates, you cannot do that. And where templates don't really map to a DOM tree, it tries to expand the range of the template so that it fits a DOM tree. So for example, normally, as we just saw, this particular template invocation with A surrounded by bold tags would map to a DOM tree. But in that example, it expands the range of the template behavior to include foo and bar, which is not really part of the template. So this is an exercise you guys can try later on. Take this piece of Wikitext, add it to a page, and try editing in Visual Editor. You'll see the behavior of editing. So basically, Parsoid tries to scope and bound the behavior of a template so you can edit it as a single unit. So the other example where Parsoid deals with DOM semantics or DOM structures is when it adds section wrappers around Wikitext sections. And so it has to handle scenarios where a Wikitext section doesn't map to a DOM tree. And there are a lot of cases like this on actual wiki pages. So here is a sales pitch for Parsoid. So broadly, Parsoid has demonstrated two big ideas. One is that it is practical to go back and forth from Wikitext. And that's how visual editing is possible. That's how content translation is possible by doing HTML editing in those products. And secondly, it can actually map an output DOM node to the input Wikitext string. And as I said, it assumes DOM structure as required to make this work. And the reason this works is because, for the most part, Wikitext on pages do the right thing. And templates, for the most part, there are a whole bunch of templates which do the right thing. But there are also, of course, Wikitext which has broken markup. There are templates which don't fit this model. And so Parsoid has a lot of hacks and fallbacks to handle scenarios where DOM semantics don't apply. So the other part of the sales pitch is Parsoid deals with Wikitext, so you don't have to. And so the implication is twofold. So if you are a client that is concerned about reading the page and analyzing the page and extracting information from the page, then you can use a spec that Parsoid publishes to query the output DOM and extract information about the input document. So for example, Google used to run and query MediaWiki to extract information for its knowledge graph. It doesn't do that anymore. It uses Parsoid's output because it's much simpler to do that. And if you're a client like Visual Editor or Content Translation, and you're concerned about editing the document, then you can do that entirely on the DOM. You don't have to deal with Wikitext at all. And then you can rely on Parsoid to map it back to Wikitext faithfully. So that is the background. So we talked about what the two parsers are and why we have two parsers. And I went through some details of HTML, DOM, Wikitext, and what the parser approach is here. So in the next part of this talk, let's look at the roadmap. So what is the history of Parsoid and where we are today and the evolution of Parsoid itself. And I'm going to also talk about why we are porting Parsoid to PHP now. You might have got a glimpse of it early on, but I'm going to talk a little bit more. And finally, what is left to actually get to the end of the road. So here is a 10,000-foot view. So I'm going to first, this is again in three pieces, Parsoid till 2015. So in 2011 and 12, which is when Parsoid was conceived of, so feasibility was entirely unknown. For example, when I joined the foundation in 2012, May 2012, a couple of people I know talked to me and were pretty sympathetic and told me that I'm joining a project which probably doesn't have much chance of success. And it was, in fact, unclear where this was going and whether we can actually get this done to map this to a DOM. So in the period 2013 to 2015, it is a period where Parsoid got established and it was clear it was here to stay. And so in 2015, so we had this realization, oh no, we have two parsers now. And also two parsers and two of other things. And so 2015 onwards, we start looking at unification. And I'm going to talk about what that all meant. So let's rewind to 2011. So this is from a page on Wiki where it says Wikimedia Engineering's key future-facing priority for 2011 and 12 is to create a rich text editing environment backed by a revamped, normalized, and more consistent Wikitext parser. So that's pretty ambitious. And so in 2011, May 2011, during the Berlin hackathon, new parser was planned, along with Wikitext Next, which I guess we are calling Wikitext 2.0, and Visual Editor. Work on this new parser started around November 2011 as part of the Visual Editor project. And sometime in February 2012, it was renamed to Parsoid. The thing to note here is, even back then, structured representation was at the core. The plan was to maybe build an abstract syntax tree of Wikitext and also maybe use the DOM. And so in early 2012, the core design of Parsoid was in place, and this is still the design we use in 2019. So you will take Wikitext, parse it to tokens, you transform the tokens, build a DOM, and then transform the DOM. And the output would also have annotations to expose information about Wikitext. For example, what kind of link is it? Is it a wiki link? Is it an external link? Is it a language link? Is it an interwiki link, for example? And it also annotates information about extensions. It demarcates extension output. It provides information about templates, the name of the template, what's the boundary of the template, what are the parameters of the template, and other meta information about the page like categories, language links, and some other things, magic words, for example. So the plan in early 2012 was to prototype this in Node.js and then port this to C++, making this a PHP extension in core. This was meant to be self-contained with fallbacks to core functionality only for extensions. But by the end of 2012, this had changed a little bit. So we had to do a lot of rapid development for the first release in December 2012. By then, we had dropped the idea of a C++ port, and we deployed the Node.js implementation. And that's how we got a parsing service. And we also dropped the preprocessor that was in Parsoid. It had a whole bunch of edge cases because the processing model was different, and it was not clear how it was going to perform. So we relied on the MediaWiki API for expanding templates to Wikitext. So overall, this particular design was working fairly well, and we still had a lot of work to do. We had a bunch of compatibility things to resolve before we could even call Parsoid feasible. So it didn't make any sense to put in a whole bunch of additional work before this was done. So we just stuck with this architecture. So of course, this led to all the subsequent debates about services, third-party support, and so on. But back at that time, it made perfect sense. So between 2013 and 2015, support for VE had stabilized, and new clients were appearing. So Flow, content translation, mobile content service, which is behind Android app. Google was using this, Kiwix is using this, and with the GSOC project, we also built a prototype of a Wikitext linting tool, which we fleshed out later during tidy replacement. I'm going to talk about that later. In this period, we also had to start dealing with the ramifications of a different Wikitext pipeline and a different processing model. And we also had to deal with the fact that Wikitext as a syntax was not really designed for going from HTML to Wikitext. So we had to deal with a whole bunch of issues around escaping Wikitext and editors becoming unhappy about all the no-wiki annotations and trying to introduce a lot of heuristics to reduce those. And of course, on different wikis, editors were used to different kinds of template formatting. And so we had to deal with template formatting issues. And we had to deal with dirty diffs. Now, the reason all these things matter, dirty diffs, escaping formatting, is because, once again, the canonical representation of a page that editors are used to is Wikitext. And a lot of the workflows on that editors and admins have, really advanced editors, is entirely based on Wikitext, and it's based on Wikitext source diffs. So it makes sense, Wikitext diffs. If you add dirty diffs, then they make their workflow really hard. So anyway, so I think all this makes the work of Parsoid harder. And in this period, we also started helping third-party users with their parser installations and provided a Debian package for Parsoid. It was also in this time that the debates around services heated up, and Parsoid became the poster child for the debate. So I'm going to talk a little bit more about what I meant about ramifications of a different Wikitext model. We looked at this a little bit before. So we have templates that produce strings that have no equivalent in the DOM. For example, you could have templates that produce just an opening tag of a div. There is no way to represent that in a DOM. You either have text or you have the entire content of a div. You have the opening tag, closing tag, and the content of the div. You cannot just take a div and represent that in the DOM. So for example, there are info box styling templates that produce the style of the info box, but also produce something else, a part of a tag. So once again, you cannot represent that in a DOM. You have table cell style templates, which emit something else. And there are templates which produce table start tags, end tags. And so this means we have to deal with template boundaries while respecting DOM structures. So we looked at this earlier with that example. And so rectangles in this case show the boundaries that Parsoid creates for templates, depending on what the Wikitext is. And we also started realizing that we need Parsoid specific versions for extensions. So we have site, gallery, poem, and a bunch of others. And we also had to deal with bad markup, and we had to round trip it back without dirty divs. I mentioned this earlier, because editors would be unhappy if we did that. And I'm not going to go into the details here, but we can if this comes up in Q&A. One of the most prominent markup errors is what is called fostered content. And this is when content is embedded in tables at the wrong place. And this is HTML5 spec thing. And as you know, on wikis, templates are very common. Tables are very common. And so fostered content errors are also fairly common. And this has been a source of a fair bunch of complexity in Parsoid code base. So now that Parsoid has been established, we started thinking about what does it mean to go to a single parser? How do we use Parsoid output for both read and edits? And also in this time, we had to deal with the fact that Parsoid is a service, and there is interaction between Parsoid and MediaWiki. And so Parsoid has been making a lot of API requests to MediaWiki. So we built an extension, the Parsoid batch API extension, to reduce the request volume. And we also had to deal with timeout issues because of cascades between services, retry cascades on timeouts. So this was the time where we were stabilizing Parsoid in terms of performance, deployment, and QA. So we had about 8 Parsoid incidents between 2013 and 15, 4 of them in 2015. And as part of the work we did in 2015, we could stabilize it sufficiently that there was only one between 2016 and 18. So this brought us to start thinking about the future. So how do we start using Parsoid for reads as well as edits? So we started charting options for how to unify the parsers. We started cataloging all the ways that Parsoid was incompatible with the PHP parser. And the first step here that we identified was to upgrade core to HTML5 by replacing HTML4 tidy, because Parsoid output was based on HTML5. And which was a source of a bunch of differences in the output. And we also started speculatively planning around Wikitext 2.0. So we started writing RFCs and proposals for fixing templates, fixing Wikitext semantics. And in retrospect, this was probably a bit premature, given that we had 2 parsers, and we really wouldn't be doing this on both parsers. But at least we are well prepared for next steps when we are ready to do this. Okay, so what does it mean more specifically to unify the 2 parsers? So we have taken a 2-pronged approach. In some cases, we're going to move the PHP parser towards Parsoid, and in other cases, we're going to move Parsoid towards the PHP parser. For example, as I mentioned earlier, the PHP Parser output used tidy, which was HTML4 based. And so we started thinking of migrating that to use HTML5. And we also have a project which is not completed yet to migrate the legacy parser output, media output, to Parsoid style semantic markup. This is work in progress, which will be completed later. In other cases, we started bridging gaps in Parsoid behavior, in Parsoid output. Things like language variant support was missing, which is once again work in progress. It's mostly done at this point. That linking was missing. We've fixed that. So I'm not going to talk about all these differences. I'm going to focus primarily on this one big project that we did, which is replacing tidy. So this was meant to be a one-year project when we started this in mid-2015. But this turned from 1 year to 3 years. And there's a blog post we published last year. You can take a look at the blog post for details. So we had to do a whole bunch of things to replace tidy. So first of all, after a bunch of different attempts, we finally settled on Remix HTML, which is a pure PHP HTML5 parser. And we knew right going into this project that this is going to impact pages on wikis, but we really did not know what kind of impact we are talking about. So we built a lot of custom QA tools to figure out the impact on wikis. So first of all, we had to spin up 2 virtual machines in labs. One would run tidy, the other would run Remix. And we populated both these VMs with 60,000 pages from about 40 wikis. And we revamped some of our QA tools we had for Parsoid. And to take screenshots of a page on these 2 wikis, and then compare the screenshots and generate a diff. But the problem we ran into is that these diffs had a lot of noise. For example, if there was even a 1 pixel vertical shift, then it will show a lot of noisy diff, which was pretty much useless from the point of view of making sense of it. So we built a new tool called Upright Diff, which is based on video motion detection tool. And this was used for doing a diff. This would actually hide vertical motions, which was very important in letting us get numerical quantitative numbers, which you could then use for figuring out the impact of differences between tidy and Remix. So once we had all these tools, we then did a bunch of testing, and then this revealed that replacing tidy would potentially cause a lot of disruption on wikis. And more importantly, we realized that editors might have to fix pages and templates to actually mitigate this impact. The reason this is so is because wikis had over time come to depend on tidy specific behavior. This very inadvertently. It's not something very deliberate. It's just editors write Wikitext, and it behaved right, and they just went on with their work. But so to deal with this, we initially started adding some compatibility code around tidy to handle some issues. But it also was going to require a whole bunch of fixes to Wikitext and templates. So we had to build tools to assist editors. First of all, we got to figure out what pages were going to be impacted, number one. And given a page that was going to be impacted, precisely what piece of Wikitext on the page would have to be fixed. That's something that we wanted to help editors identify. So we built this linting tool that I talked about earlier in Parsoid, which could precisely identify a string of Wikitext for that. And we built a linting extension to expose this to editors on all wikis. And we also built a parser migration extension so that editors could actually make a fix and verify that the change to Wikitext would actually fix the page. And we then undertook 18 months of community engagement, 6 months of which was actually preparation for the engagement. And so as part of this, we published a bunch of information on Wiki, published help around linter pages, and made regular announcements, and gave wikis a 1-year window. And so progressively, we did this. So it was clear that we couldn't make the switch at all in one go. So we started doing a switch progressively based on monitoring how wikis were doing with their fixes. And we managed to get some early adopter wikis, primarily Italian, I think German, Russian, Swedish wikis, to switch over from tidy to Remix. And based on that, we discovered that there were more tidy-related issues that had to be fixed. So we again fixed code in Parsoid and the PHP Parser, and made a final switch around July 2018. And finally, we removed all tidy support from MediaWiki in version 1.33. So one thing that it was very clear from this effort is that we have a lot of legacy constraints. So here are some very prescient thoughts from the 2011 hackathon. So Tim Starling writes, there are a lot of features that people count on that rely on the current regime, indeed. And Neil K., another person in that hackathon, says, a simpler parser seems possible, but it becomes impossibly distant when we insist on not breaking anything. Of course, it's clear we cannot break pages in the process of upgradation. That would really not be acceptable. And as we see, that a lot of work has gone in Parsoid and in replacing tidy so that we can actually slowly make progress in evolving our technical stack without breaking the pages that we already have. And I think if we want to do more of this in the future, that is fix Wikitext or fix templates, we can probably use the process that we use for replacing tidy as a template. We can use Parsoid's Wikitext linting abilities and use the extensions we have, linter and parser migration, to assist editors to fix pages where required, and will of course require community engagement here. So this is the only slide on the services debate. So till about 2016, I mentioned earlier that Parsoid was the poster child in this debate on what the architecture of MediaWiki should be. Will it have services or will it have no services? Until about 2016, there was really no clarity around this, where MediaWiki architecture was going to go. More practically for us, what it meant is that the constraints around the unification of the parser were very unclear. So in 2017, all this came to a head. There were more debates, there were position papers, there were conversations, working groups, and summits. And all of this eventually led to the Platform Evolution Program in 2018. And the parser unification was one of the components of this platform evolution. And one of the first steps was porting Parsoid to PHP. So let's talk about why this actually makes sense, porting Parsoid to PHP, because it's going to add more work, right? We are trying to unify parsers, and now we are going about porting. Now, I think it would make sense if we look at what we talked about early on. So let's bring back the genie here. So there were two wishes we made to the genie, where we ended up with a single parser. Wish 1 involved porting Parsoid to PHP, and wish 2 involved porting a subset of MediaWiki core and extensions to Node.js. In both cases, we still have to fix Parsoid, whether it's PHP or Node.js, to address output and feature differences. And here is the reason why wish 1 makes sense. And the underlying assumption here is that we got to fix the service architecture of Parsoid. First of all, it makes sense because it's a limited scope. All you need to do is port the Parsoid code base to PHP, versus an unknown scope where we say port a subset of MediaWiki core and extension to Node.js, because we don't know what else we'll discover when we do that port. The second important reason why it makes sense is when we identify feature gaps, we can actually leverage core code to bridge those gaps. For example, internationalization and localization support for extension is missing in Parsoid right now, and we can just use core code when we port this to PHP. There are some other side effect benefits from this. Non-wikimedia wikis get a simpler install in some cases. Visual editor and the linter come to them for free. And we're going to get a potentially simpler code base in Parsoid. There is no async code. There is no code to talk to MediaWiki. And as we realizing, we are expanding the exposure to Parsoid code base to others during the sport. And we hope eventually, I think there will be a little bit more clarity about services once Parsoid exits the services debate. Okay, so once we port to PHP, how do we get to the end of the road? So here are some milestones. First thing is to finish the port and take Parsoid.js out of service, and no pun intended there. And we think it's probably going to take 4 to 6 calendar months. We'll see what happens there. And finish some of the other projects like fixing the media output, fix the already known bugs, finish implementing language variant support, identify any other Parsoid feature gaps, and bridge with core code, for example, internationalization support. Most importantly, we have to fix Parsoid performance. So in order to actually map the input and output and enable clients to work on the DOM, Parsoid does a lot more work than the current PHP parser and is going to be slower. There's really no way around it right now. So this will require some serious performance work, including even potentially throwing hardware at the problem at some point. And then we got to focus on making Parsoid the default on Wikimedia wikis. So which means we have to establish regular QA runs to identify any uncaught issues. Just like we compared tidy and remex, here we're going to compare Parsoid output and the PHP parser output. Maybe run it once a week and see what we find. Analyze the results, file Parsoid bugs, identify if there is anything that editors need to do on wikis, similar to the tidy replacement. And we got to finalize a new parser hooks API and migrate over Wikimedia extensions. So I think we anticipate this is probably 18 to 24 months from now, but it could be sooner depending on how things progress and depending on how many people get involved here. Since I think we are probably close to end of time, I'm going to skip this. But broadly, I think the reason why we need to change this is because the internals of parser are different, and we just cannot use the same hooks that we currently have, which are based on the PHP parser internals. And finally, I think once we are done with this, we can focus on MediaWiki by publishing the new parser hooks on API, publishing docs around fixing extensions, and following the deprecation process. And hopefully that will bring us to the end. So this is just a slide of who's been involved so far. So the names in bold are the people who are currently involved in the porting effort. And the names in blue is the parsing team. And the names in green, Brian, Gabriel, and Trevor were the ones who were involved originally in kicking this project off. And the others were have been involved with Parsoid at different times. And thank you, everyone. Okay, I'm done with the talk, and I can take questions.
Thank you, Subbu. So feel free to ask questions on IRC. Subbu, if you'd put that slide up again that has the information about IRC, which channel, and then also you can ask on the YouTube stream, or if anybody in the room has questions, let me know.
Do you see the slide?
Yes.
Okay.
I think I'm going to do the 7-second rule. If we don't hear any questions in 7 more seconds, then I will assume that we do not have any. If you don't have a question, or if you have a question later after thinking about it, do feel free to either ping Subbu, or you can also ask me and I can send the question along to him as well. Oh, okay. We'll give everyone on the stream a minute to catch up. Yes, it just reached the end. I see that there's a question on the IRC channel if the slides will be made available, and yes, they will. They'll be made available after this talk, and I'll send out an announcement where you can find them. And then we also have a question for you, Tsubu. Is the rollout timeline 24 months?
I mean, I anticipated probably it's going to be 24 months before we actually can replace this on the Wikimedia cluster. Yeah, because I think there's still a bunch of work to be done. Most importantly, finishing the actual port, and after that is when we can actually get on with the rest of the unification project. Yeah, so I think it'll probably be 24 months from now.
And then we have another question for you. Would you recommend that editing tools or bots start using Parsoid instead of Wikitext?
I mean, it depends on what you're trying to do, and I definitely recommend checking out Parsoid spec because it's going to be much simpler. You can just use HTML manipulation. So that's definitely my recommendation to check out, and we can provide you more information and help if you require to switch to Parsoid. I mean, just to kind of give you a sense, right? So the library that bots use is called MW Parser from hell, and that I don't know why it was named that. I think I assume it is probably because it's hard to parse Wikitext, presumably, and so I think it's probably going to be simpler if you just used HTML in some ways. But again, it depends on what you're trying to do.
Okay, any other questions from IRC or in the room? Oh, one more question. Will there be a formal spec of Wikitext?
So I think one of the three goals of the parsing team was improve Wikitext and make it easier to use, parse, and not make errors. So I think we would like to publish some spec at some point, but it would be hard while we have two parsers. I think once that will require making parser the default and deprecating certain behavior and fixing some corner cases as undefined. And yeah, I think we would like to, yeah, but we may have at some point, but it's not right away. And definitely, if we move towards Wikitext 2.0, it will have a spec in terms of behavior and all of that. Yeah. Any other questions?
I don't see any other questions. I do see that there is a comment that a formal spec of the HTML DOM, more or less. I think Siska on the chat on the
Office channel,
yes,
yeah.
Office channel. Thank you.
Yeah.
Mentioned that. So.
Yeah, I think so. I mentioned earlier that I think if you're a tool, you can just use the output of Parsoid, and that output is spec'd and it's versioned. And so if you're actually only dealing with HTML, then that should probably be sufficient for you as a tool writer. And I think we also have, because it's version, we also have a protocol for how to upgrade the versions, and it won't just break on you. So there is a content negotiation protocol, and so you can pass the version header, and you can continue to use the old version till you get a chance to upgrade. But yeah, there's a spec for the HTML output from Parsoid.
Okay, we'll give everybody just another minute to ask any questions if they have them.
Okay. I'm sad I didn't get to play the Beatles. Okay.
You'll have to play it for us the next time you visit.
Yeah, right.
Yeah, you can take it up with Sony.
Okay.
Well, I think that's it for questions. And again, if you do think of something later and you want to reach out, please do. We'll be happy to pass those along to Subbu. Once again, thank you, Subbu, so much for doing this first Tech Talk of this new season. We're so excited to get started, and I'm really grateful to you for being a person who was willing to step up and do the first one and really help out with these. So thank you.
Thank you for all the work organizing this.
All right.
Right.